Hello everyone. In today's class we will see cascade amplifier or multi-stage amplifier. In the earlier class we have seen about a single stage amplifier and it's some of the numericals of single stage amplifier. Okay, so if you see that single stage amplifier, okay, the point in the single stage amplifier, that is the gain. Okay, so gain of that particular amplifier is, you can say, less. Okay, so I'm talking about a single stage amplifier, single stage amplifier. Okay, so in single stage amplifier, gain is less, gain is less. Okay, and then input and output resistance requirement cannot be met. So input and, you can say, output resistance requirement cannot be met. This is what one of the disadvantages of single stage amplifier. Then we talked about efficiency. So efficiency in terms of single stage amplifier is very poor efficiency. Also, in single stage amplifier we have seen that frequency response of amplifier. Okay, so we have plotted the curve about the voltage gain, and then this is what the voltage gain of the amplifier along with the frequency. Okay, along with the frequency. So we have found this curve. Okay, so this is what the gain of the amplifier, which is, you can say, which is constant. Okay, which is constant at okay, so gain at constant at few frequencies. Okay, and then we taken as 3 dB frequency. Okay, where this portion is my this frequency is called as FL or low frequency, and this frequency is my FH, that is high frequency. Okay, and we can say that the bandwidth. Okay, so bandwidth is nothing but fh minus fl, so this is what my bandwidth is there. Okay, and in the single stage amplifier, if you see that the gain, okay, so gain multiplied by bandwidth, gain multiplied by bandwidth is nothing but a constant value, is nothing but a constant value. Okay, whereas if you see that multi-stage amplifier, in the multi-stage amplifier, okay, that gain is increases. So in real time, okay, in real time, if we need an amplifier which can amplify a signal from a very weak source, okay, very weak source, such as, you can say, that microphone. Okay, and we want to amplify that signal. Okay, we want to amplify that signal because we are going to use that particular signal in another transducer. Okay, so an amplifier which can amplify a signal from a very weak source, such as microphones, to a level which is suitable for the operation of another transducer, such as, you can say, loudspeaker. So how do we amplify? So in order to achieve this, we need a cascading of number of amplifier stages. So cascading of number of amplifier stages is nothing but the multi-stage amplifier or cascade amplifier. Okay, so in multi-stage amplifier, that gain is there. Okay, which we have seen that gain is less in single stage amplifier. So in multi-stage amplifier, that gain is high, but there is a disadvantage also. In multi-stage amplifier or cascade amplifier, your bandwidth is low. Okay, your bandwidth is low. So let us see the first we will see a two-stage cascade amplifier. Okay, so let us see a cascade amplifier, that is a two-stage cascade cascaded amplifier, two-stage cascaded amplifier. Okay, so I will draw the diagram of two stage cascaded amplifier. So likewise, we have, this is what stage one, this is my stage one. Okay, and then I'm cascading another stage. Okay, so it can be a different configurations. Likewise, I will give you an examples. Okay, so one stage is common collector, common emitter amplifier stage. Okay, that is common emitter amplifier, and then we are coupling this second stage with the common collector amplifier. Likewise, so this is my stage one and stage two. okay, the voltage. Okay, now I'm you can say I'm coupling this, or I'm joining these two stages, so it will make it as a cascaded amplifier. It will make it as cascaded amplifier. So joining, or you can say yes, and then here you can apply AC voltage. Okay, and yes, of course there is one source resistance is also there, that is RS. The voltage across this input side is my V, is my V, or if I give you it is as VI. Okay, that is VI for I for input, and then I will give it as name, that is VI1. Okay, that is at stage 1. Output at this particular points, output voltage at this particular point is my VO, that is output voltage at one stage, that is first stage. So I will mention it as VO or V01. Okay, whereas if you see that the input to the second stage, likewise we have mentioned input to the first stage as Vi1. Here I will mention input to the second stage as Vi2, and then I will take output across a load resistor. I will connect a load resistor to this, that is RL, and then output across this stage 2 is my VO2. Okay, this is my Vs. So this is what you can say block diagram of, you can say, a two stage amplifier. So these stages are connected, stage 1 and stage 2, such a way that the output, okay, so this is what the output of the first stage, okay, it is connected to as a input of the second stage. Okay, input of the second stage. Okay, so if I wanted to calculate overall voltage gain, okay, if I want to calculate overall voltage gain, that is my output voltage divided by my input voltage. Okay, so here if I want to calculate output voltage, that is VO2, divided by my input voltage, that is Vi1, is nothing but the overall voltage gain, or I will define it as in terms of AV. Okay, but if you see that VO2 by Vi1, okay, so this is my VO2, this is my Vi1, but here I am having some input stage. Okay, the two stages are there, so I will define this output, that is voltage gain for this first stage, and then voltage gain of this second stage. So how do I define? So I will define voltage gain at second stage first. Okay, so I will define it as VO2 divided by Vi2. Okay, divided by Vi2, and then multiplied by the second, this first stage gain. Okay, that is multiplied by first stage gain, that is my Vi2. Okay, this is, you can say, VO1 is equals to Vi2. Okay, so I will define it as Vi2. Okay, Vi2 divided by, this is my Vi1. Vi1. Okay, how I define it? VO1 is nothing but Vi2. Here you can see that Vi2. Okay, so output of stage 1, output voltage of stage 1 is VO1. Okay, and input to this stage 1 is the same, whatever that is at the output. Okay, so that's what I mentioned here. So how do I write now? VAV, that is my voltage gain, as VO2 divided by Vi2. Okay, and then Vi2 is there. I can replace this Vi2 as a VO1. Okay, because both are same, so I will rewrite it as VO1 divided by VI1. VI1. Okay, this is multiplication factor. So what is this? VO2 divided by Vi2 is nothing but my voltage gain of second stage, multiplied by voltage gain of my first stage. So AV is nothing but AV2 multiplied by AV1. Okay, AV2 multiplied by AV1. Okay, so you can say that voltage gain of multi-stage amplifier is nothing but the product of voltage gain of individual stages. Okay, here two stages are there, stage 1 and stage 2. So voltage gain, or you can say overall voltage gain, is nothing but the product of two individual voltage gain, okay, of individual stages. Okay, so if you see this particular block diagram, so here we have not made we have not considered any of the biasing arrangement, okay, only in order to simplify this particular circuit, okay, particular things, okay. Let us take an example, okay, let us take an example based upon this, okay. So the examples is like a problem, okay. I will take one problem on this. So for the two stage, okay, I will write down the problem statement for the two stage, okay, for the two stage, what is stages, that is CE dash CC, that is common emitter common collector amplifier circuit, amplifier circuit as shown in the figure, okay, as shown in the figure. So I will draw the figure first, okay. uh, yes, so I will draw, this is my first stage, okay, that is my common emitter amplifier, okay. This is my transistor, common transistor, and then I can say source resistance is there, that is my RS, and then input as you can say sinusoidal, that is my VS, and then this comes out to be as the ground. Fine. Now here I will draw one collector resistance, then this is what VCC, okay, and then I will draw another transistor. This is the second transistor I am drawing, okay. So this part is connected to this, and then this is what my RE2, which is equals to 4.7 K, okay, and then here the output voltage is measured. So me by VO, okay, plus and minus. Fine. So this is my plus VCC. Okay, here plus VCC is there. Then this is what my first transistor. This is second transistor. The source resistance is there. Okay, and then source voltage is there. And then output is I have calculated. So this is my common emitter, common collector amplifier circuit. So one stage is common emitter, and the second stage is common collector amplifier circuit. Okay, sorry. And then we need to find out. Then we need to find out the input and output impedance, okay, input and output impedance, input and output impedance, and okay, then individual as well as overall current gain and voltage gain, current and current and voltage gain, current and voltage gains. Then what they have provided, the H parameter of the transistor at Q point R. So H parameter of the transistor at Q point they have provided, that is HIE is 2K, HFE is 50, HRE is 0, and HOE is also 0. Okay, so common emitter, common, you can say collector amplifier. So in order to solve this, we need to convert this two-stage amplifier circuit, okay, as a AC equivalent circuit. So I will draw the AC equivalent circuit. Okay, so before starting the analysis of this multi-stage amplifier, okay, you should note that multi-stage amplifier, that output impedance, you can say output impedance of one stage, okay, but that is one stage, okay, if it is multi-stage, okay, here two stages are there. So output impedance of one stage is, you can say, shunted by the input impedance of the next stage, okay, and that's how we need to find out the all the calculations, okay. So in order to calculate, so conveniently we can calculate the first that current gain, and then input impedance, then voltage gain, and then output impedance. Likewise, you can, if you make a sequence, then it will be easier to calculate all the parameters. So first you need to consider, or we need to draw an AC equivalent circuit for the two-stage amplifier. Okay, so I will draw that AC equivalent circuit. Uh, so I will draw. This is my source resistance. Then I need one transistor here, that is the first transistor, okay. Then this transistor collector is there, this is my collector of the transistor, and this is base of first transistor, okay. And this is my RS, the current flowing through this, you can say, resistance is as this is the first stage, so I will make it as IB1, okay, IB1. Here I am having that voltage source, okay, Vs, okay, plus minus this side, and then go down, and this is my B1, okay, base 1 I will define, because I have two stages, so I will define this as first base, so B1, and then voltage across this is my Vi input as 1, Vi1, and then this is my emitter, this is my E1 I will define, this is C1, okay, if I'm mentioning that 1 and 2 for this stage, okay. So this is base B1, this is collector terminal, that is C1, and this emitter terminal, that is E1. This is at one stage, okay. Then I'm moving about this, then I'm having second transistor here, okay. So this is the science transistor symbol, and this is collector, or I will make this as a C2, make this as a C2, and yes, let me draw this straight line again. And this is what common collector, okay. So common collector, so collector will be common and input and output side. So this is what I'm doing it, okay. That is common collector amplifier, and then my E terminal is from E terminal I will, okay, I will add RE2 here, I will add RE2 here, here I will get an voltage, output voltage, okay, output voltage, you can say VO. So if yes, and yes, so this is my, you can say, base 2 here, this is C2, and then this terminal is my E2 terminal, okay. This is my transistor 1, this is my transistor 2, and then if you take then voltage, okay. So voltage across this terminal is my VO1, or I will write it as VI2, okay. That is my input voltage at the second stage, okay. And what is that second stage? So output voltage of this. So this is what the cascading. Okay, so whatever that output voltage is there, that will be as acts as an input to this, you can say, second stage. Fine. And if we calculate the output resistance or output, so this is what, if you see that output resistance RO1. Okay, and in the similar way, okay, if you similar way, if you see that output resistance, okay, at this side, okay, so you can see that this is my R dash, okay, O1. Okay, and then input resistance at this collector side, if you see from this end, okay, so it is like Ri2. And then output resistance at this side, we can see that it is RO2. Okay, across this Re terminal we have R dash O2. Okay, we have this R dash O2. So as I told you that, so in multi-stage amplifier, your output impedance of one stage is shunted by the input impedance of the next stage. Okay, output impedance is shunted by the input impedance of the next stage. Now we have drawn this AC equivalent circuit. Now in similar way we have to draw an H parameter circuit. Okay, H parameter model to this particular circuit. Okay, so I will keep this diagram as it is. Okay, and I will draw H parameter. Uh, I will name this as AC equivalent circuit. This is my AC equivalent circuit. Now I will draw, you can say, H parameter model. So this is my source resistance RS, input Vs plus minus. Okay, and then if I consider this as my B1, now this transistor is there. Okay, I have to need to apply the, you can say, H parameter model. So I will add here HIE, HIE. Okay, HIE, and then this is my emitter terminal 1. Okay, and then I need an independent current source here, and then this is my C1. So for this, okay, yes, I, of course this is HFE into IB. Okay, this current, and this is C1. Then you need to add, this is your RC1, and then the second transistor, that is my B2. Okay, this is my base, and then this you can write it as HIE. Then this is HFEIB, and then RE2, and across these two terminal we have output voltage VO. Okay, so this is my base B2. Here I will get an emitter terminal, that is E2, and yes, this is what my collector terminal, this is common collector. Okay, so C2 here. Okay, now I will draw an current, you can say, current directions. Okay, if you look at this, the current which is flowing through this, you can say, base resistance. Okay, I will change the color. What is this? take this color. Okay, so the current flowing through this is my IB1. This is my VI. Okay, VI voltage E1. And then if you see that from this side, so you will get an RI1. Okay, input resistance at 1. Okay, RI1. Here you will get an RO1. The current flowing through this is my IC1. Current flowing through this base terminal is my IB2. Look at this at this side, so you will get an R dash O1, and this side you will get an RI2. If you look from this side, so you'll get RO2, and then yes, this is what my output impedance RO2. Okay, output impedance RO2 or RI1, or input impedance, you can say that. And then current across this is my IO, that is output current. Current across this E terminal is my IE2. Okay, IE2, and this is IB2. Yes, all the current directions I have made. Okay, so you can then calculate. Okay, it will be easier if you want to calculate the if you are going to calculate the current gain. Okay, individual current gain, and then overall current gain and voltage gain. So this is my approximate H parameter model. Approximate H parameter model. Now just there is calculations now. Okay, so the first calculation is the analysis of single stage, analysis of individual stages. Okay, so okay, so in multi-stage amplifier you have to go through the last stage first. Okay, you have to analyze this last stage. Okay, because you can say that because input to the second stage, okay, is nothing but output of first stage. So you have to go from second stage. Okay, here two stages are there, so just go to the second stage. Okay, so we'll do for analysis of second stage. So second stage is nothing but my CC, second stage CC, that is common collector amplifier. Okay, so you need to find out the current gain first. So with the help of approximate model, you can do this current gain. So I will make it as AI2. Okay, capital AI2. Okay, so capital AI2 is nothing but 1 plus HFE. So what is HFE? HFE has been given as a 50. So 1 plus 50. So 51. 51 is my AI2. Similarly, you can go for input resistance. Input resistance. Okay. So RI2, input resistance. So it is nothing but HIE plus 1, 1 plus HFE multiplied by RE2, multiplied by RE2. So what is HIE has been given? So HIE has been given as, what is this value? HIE has been given as a 2K. Okay, HIE has been given as a 2K. So that is equals to 2K plus 1 plus 50 into 47, 4.7. Okay, 4.7K has been given into 10 to the power plus 3. And if you calculate this, okay, so if you see that, The value of Re2 is 4.7 K. Okay, and if you calculate this, okay, that multiplication, so you'll get to know that this value is 241.7 kilo ohm. So input resistance Ri2 we got, that is 241.7 kilo ohm. Now we can calculate voltage gain now. So voltage gain, that is AV2, is nothing but current gain multiplied by load resistance. Okay, so what is current gain of that stage? Current gain ai2 just we have calculated, multiplied by the load resistance. So RL2, I will write it here, load resistance divided by input resistance, that is Ri, or input impedance, that is Ri, and here second stage is there, so all subscripts are 2. So what is RL2 now? Load resistance. Load resistance is nothing but my emitter resistance. Okay, so I will write the equation as AI2 multiplied by RE2 divided by RI2, and which comes out to be put the value of AI. Just we have calculated current gain value at second stage, that is 51. Okay, 1 plus HFE. So 51 multiplied by RE2, 4.7K. 4.7K divided by input resistance, just we have calculated, that is 241.7 into 10 to the power plus 3. So my AV2, which comes out to be 0.991. 0.991. So we have completed the analysis of second stage. Now in the similar way we need to calculate, or we need to analyze the analysis of first stage. Okay, so analysis of first stage. Analysis of first stage, that is my common emitter amplifier analysis. Now common emitter amplifier analysis, the first one is my current gain. Okay, so first stage I will make it as AI1, which is nothing but minus HFE. Okay, just see the formulas. Okay, see the formulas for H parameter model, approximate H parameter model, that is for common emitter, common collector, and common base. Okay, and then you can change, you can make it change also. Okay, if you know the conversion formulas for this H parameter model. Okay, so voltage gain you can sorry, yes, current gain you have calculated, that is minus of HFE, that is nothing but minus of 50. This is my AI1. This is my AI1. Similarly you can calculate input resistance. Okay, input resistance, that is my Ri1. I am making it as Ri1. Okay, and which is nothing but the HFE, that is nothing but 2K. HFE is nothing but 2K. The third parameter is my voltage gain. I need to calculate voltage gain of stage 1. So AV1 I will mention. So what is the formula for AV1? Is nothing but AI1 multiplied by RL1 divided by RI1. Okay. So what is RL1 now? RL1 is nothing but, if you see that what is RL1. Okay. So come back to this. Okay. So RL1 is nothing but you can say that input resistance is there. Okay, so input resistance, which is uh, uh, Ri2. Okay, here input resistance, that is Ri2, which is in parallel with your RC1. Okay, so RC1 parallel with Ri2 is nothing but my RL1. RL1 is nothing but RC1 parallel with Ri2. Okay, so 3.3K is my RC1, which is in the parallel with 241.7K. and this comes out to be 3.25k. This is my RL1. So if you put the values of RL1 in the formula of voltage gain of first stage, okay, that is AV1. So AV1 is nothing but minus 50, okay, that is AI1 multiplied by RL1. So what is RL1 value? That is nothing but 3.25k divided by RI1. So RI1 is nothing but 2k. So AV1 is nothing but minus of 81.25. So we have calculated, or we have find out the analysis. We have done analysis for stage 1, we have done analysis of stage 2. Okay, so stage 2 is common collector amplifier, stage 1 is common emitter amplifier, and we have calculated the current gain, input resistance, voltage gain for every stage. Now we need to find out the voltage gain, or you can say overall voltage gain. So overall voltage gain is nothing but the multiplication of individual voltage gain, just we have seen. So overall voltage gain, overall voltage gain, AV, overall voltage gain is nothing but voltage gain 1 multiplied by voltage gain 2. So voltage gain 1 is nothing but this value minus 81.25 multiplied by 0.991, and which it comes out to be minus 80.51. Okay, so overall voltage gain, and then overall voltage gain by considering source voltage. Okay, so that can be defined as AVS. Okay, if you consider as overall voltage gain considering source voltage, so VO divided by VS by looking at this particular diagram. Okay, so yes, going back to this diagram again. So this is what VO and this is what VS. So overall voltage gain considering the source voltage is VO by VS. Okay, and what is VO by VS? So VO, okay, by V1, VO by V1, or you can say that is what VO by input voltage divided by, okay, so here you can see that input voltage here, okay, so VO by V1, okay, or you can say VI, and then VI by VS, we can write this equation. So yes, I will redraw this particular diagram. Okay, so what is VO by VS? VO by VS is nothing but VO by VI, that is input voltage, and then V input by Vs. This is what overall voltage gain considering the source. Considering the source. Okay, so if you see that particular diagram, so we have this is what the source voltage. Okay, that is my Vs plus minus, and then we have a source resistance, and then we have this, you can say, input resistance, okay, at that right particular side. Okay, so this is my input resistance, I will write it as Ri1, this is my Rs, and if you see that voltage across this is my Vi. Okay, so AVS is nothing but VO by VS, and that is equals to VO by VI multiplied by VI by VS. So this side, okay, VO by VI we know, and then VI by VS is by looking at this diagram. Okay, so what is Vi now? If you look at this particular diagram, what is Vi? So Vi is nothing but Vs times Vs times Vs times Ri1 here, Ri1, okay, Ri1 divided by this addition of these two. So Rs plus Ri1. So AVS is nothing but VO by VI here as it is, and then by VI by Vs. So for VI by Vs, you can write down this as Ri1 divided by Rs plus R1. Okay, if you manipulate this equation. So I will write VO by VI multiplied by RI1 divided by RS plus RI1. This, what is this term? AVS. So this term VO by VI is nothing but AV, that is voltage gain, multiplied by this factor, multiplied by RI divided by RS plus RI1. Okay, Rs plus Ri1. Now you know all the values for this. Okay, so what is voltage gain? It is nothing but minus 80.51, that just we have calculated, multiplied by Ri1, that is my 2k divided by 1k plus 2k. And if you take if you calculate these equations, so you'll get this value, that is AVS is your minus of 53.67, minus of 53.67. Now in the similar way, we can calculate the output resistance. Output resistance, that is my RO, that is my RO. So if you look that RO, okay, if you look that RO, if you look at RO, that is output resistance. So output resistance here, okay, the output resistance here, if you look at this, so output resistance is nothing but RO2, okay. So output resistance, that is nothing but your RO2, which is in parallel with your RE2, which is in parallel with your RE2. Okay, so first we will go by one by one. First we will calculate this R dash O1. What is R dash O1? R dash O1 is nothing but your RO1. Okay, this is what your RO1. So which is your RO1, which is in the parallel with RC1. Okay, so I will do it this calculation as here. So R dash O1. Okay, R dash O1 is nothing but RO1 parallel with RC1. Okay, but as you know that RO1 is infinity. Okay, so R dash O1 is also infinity in parallel with 33k. RC1 values, RC1 is value of RC1 is 3.3k. RC1 value is 3.3k. 3.3k. Okay, so R dash O1 is nothing but 3.3k. And then we have this RO2. Okay, so what is RO2? RO2 is nothing but your RS plus HIE. Okay, RO2 is nothing but your RS plus HIE divided by 1 plus HFE. 1 plus HFE, we can directly rewrite this RS as R dash O1, R dash O1 RS. Okay, plus HIE divided by 1 plus HFE. And yes, and if you calculate this RO2 value, okay, so R dash O1 is nothing but 3.3k, this value, and then plus HIE is 2k divided by 1 plus 50. So your RO2 is nothing but 103.5 ohm. 103.9 ohm. Okay. And then what is the output resistance now? Now we can easily calculate output resistance is RO2 in parallel with RE2. See here RO, that is output resistance. So it is nothing but RE2 parallel with RO2. So we got the value of RO2. We know the value of RE2. So we can easily calculate, that is 103.9 parallel with 4.7K, and which comes out to be 101.65 ohm. This is the value of output resistance. Output resistance. Now we can calculate the overall current gain. Overall current gain, that is my AI now. So if you see this diagram, okay, so you can see that overall current gain, that is my AI. Okay, if you look at this approximate H parameter model, so you can see that that is output current, that is IO. Okay, output current, because we are calculating current gain. So overall current gain, so output current divided by the current at this side, input side, so IB1. So IO divided by IB1 is my overall current gain. IO divided by IB1. But what is this value? IO divided by IB1 value. Let's go back to this diagram. Again, this approximate model. IO divided by IB1. So here it will comes out to be IO divided by your IE2. IO divided by IE2, and then uh, uh, your IE2 divided by IB2, IB2 divided by IC1. Fine. Let us write down this. I will write this as IO divided by IE2, IO divided by IE2 multiplied by IE2 divided by IB2 multiplied by IB2 divided by IC1 multiplied by IC1 divided by IB1. Okay, so this is what my current gain value, but you can see that IO divided by IE2 is nothing but -1, and IE2 divided by IB2 IB2 is nothing but minus of AI2, that is current gain of my we can say second stage, and and IB2 divided by IC1 is nothing but minus of RC1 divided by RI2 plus RC1. Okay, so this RC1 we know the value, so we can put 3.3K, 241.7K plus 3.3K, and so this values comes out to be minus of 0.01346. And then the last value is like, we have this IC1 divided by IB1. So this is nothing but the current gain of first transistors. Okay, for first stage. Okay, current gain of first stage. So we can put all the values, and then we can calculate the value of overall current gain, that is AI. Okay, so first one is IO divided by IE2. IO divided by IE2 is equals to -1, then AI2 multiplied by minus 0.01346 multiplied by minus of AI1. AI1. So -1 multiplied by minus of 51 multiplied by minus of 0.01346 multiplied by minus AI1 is -50 So AI is nothing but minus of 34.323, 34.323. So we have solved these examples. We have calculated current gain, voltage gain, input impedance and output impedance of this two stage, that is common emitter, common collector, CECC amplifier. Okay. Now let us move ahead to this next. That is, if we cascade n number of, you can say, amplifiers, so that we will call it as multi-stage amplifier with n number of stages, n number of stages, or we can call state it as n stage cascaded amplifier. N stage cascaded amplifier. Okay, so the gain, as you know that if you want to increase, or if you want to amplify the gain, or gain of the amplifier can further increase by connecting more number of stages in cascade form, more number of stages in cascade form. Okay, and then likewise here. Okay, so in the earlier case we have seen that the stage 1. Okay, then we have this stage 2, and yes, I will make it as stage n now. So there are n stages and they are cascaded. Okay, so in between these two stages many stages are there, that's why we have mentioned this as stage n. Okay, so stage 1, stage 2 and stage n. Then we need to calculate, yes, we need to draw a Vs. This is my Vs and this is my Rs, the input voltage. So Vi1 I will make it as, then current, which is my I1 flowing through this, and the output across this. Okay, so this voltage is nothing but VO1, and the same voltage which is applied at the input. Okay, that is Vi2. Okay, because of the second stage is there. Then output at this stage is my VO2. Input to this stage is my VIN, n stage input voltage, and then I'll calculate the voltage as VON, and then this is my, can say, load resistance. Okay, so the current flowing through this circuit is my IO because of output current. Here it is input current. Okay, so voltage gain of multi-stage amplifier, as we already seen that voltage gain of multi-stage amplifier is nothing but the product of their voltage gain at individual stages. Okay, so if we talk about AV, so AV is nothing but AV1 multiplied by AV2 multiplied by AV3 dash 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 AVN. Okay, and if you want to calculate the voltage gain of any kth stage. Okay, so voltage gain at kth stage is AVK, we can mention. Then this is nothing but AIK multiplied by road resistance, that is RLK at k stages, and then RIK. So likewise we have already calculated. Okay, RIK, where your RLK is nothing but the load resistance of the kth stage. Okay, and RIK is nothing but the input impedance of the kth stage. Input impedance of the kth stage. Yes, so I think we will stop here right now. Okay, and in the next class we will see that types of, you can say, gain is measured in terms of decibels, and then we will see types of couplings. Okay, type of couplings. Okay, in order to make this multi-stage amplifier we have to couple each stage. Okay, we have to couple each stage. Okay, so there are three types of couplings are there, even four types of couplings are there. That couplings we can we will study in the next class. Okay, so that's all for today's class. I will stop it right now.